Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
Hello, and welcome to another edition of the Web Platform Podcast. This is episode 80, Getting Started with CouchDB. I'm your host this week, Justin Ribeiro, and returning to our panel, we have Sharon DiOrio. Hello, Sharon. Welcome back.
Hi.
Our guests this week are a couple of folks who work on and love CouchDB, Lehnardt and Garren Smith. Gentlemen, how are you both doing today?
Hey, how you doing?
Totally talking over each other like professionals.
That is the way we do things here at the Web Platform Podcast. So tell us a little bit about yourselves.
Garren, you want to go?
Sure. Obviously, my name is Garren. I'm based in South Africa. I'm the founder of Red Comet Labs. We do bespoke software development, mainly JavaScript development. And then I'm on the CouchDB PMC, which is the project management committee. I've probably been involved in CouchDB about 3 or 4 years now. I really enjoy it. It's a great community, a lot of fun there, and it's a really cool project. And I have spent the majority of the time working on Photon, which is the dashboard or the web UI into CouchDB.
Cool. Thanks. It's really nice. Like, I've been with the project for a little longer, and it's really nice to hear that you're having good fun. So it's not that I don't see it in day-to-day interactions, but it's good validation for all the work. So I'm Jan. I live in Berlin, Germany. I'm the longest-standing contributor to Apache CouchDB after its inventor left in 2012. I'm also the vice president of Apache CouchDB at the Apache Software Foundation, which is my favorite title because it fills full screen. Which usually means I have to read and write more emails than others, so it's not a lot of honor there, but I like to carry it around. I'm also the co-founder of a company called Neighborhoody Software that does all sorts of stuff with CouchDB and Hoodie, which may be the topic of another podcast. My company also does a thing called Greenkeeper, which helps your NPM dependencies stay up to date by sending you automated pull requests. So if you do any of that, you should check out greenkeeper.io. And
fantastic. So you guys have been around CouchDB a long time. It would be a safe thing to say at this point. Tell us a little bit about CouchDB. What's the project like? You know, what use is it to us today?
All right, Garren,
I'm going to let you go first this time.
Okay, fair enough. We're very humble. No, sorry. So CouchDB, as the name says, is a database. Its motto is relax. With a name like Couch, it's obvious that it's a relaxing product. It is one of the original NoSQL databases. When we started out, there wasn't a thing called NoSQL. We kind of tried to get a few movements going, like Alt-SQL or Alt-DB, and at a certain point, NoSQL caught on that, okay, we're one of those now. So that was good fun in 2008 and 2009. So yes, we have been around for a while. So it's a database project. Since 2008, we've been with the Apache Software Foundation, which is where software projects go to grow a sustainable community, which we've done ever since. We've got 51 people contributing on a regular and irregular basis. It's a database system. At the fundamental level, it does what all other database systems do. Storing data, receiving data, giving you back data, letting you query data. Our specific flavors are HTTP as a protocol to talk to CouchDB, and JSON as the thing to store data. Kind of regular modern web stuff, but when we started, that was kind of cutting edge, or nobody has done this before, and people called us names for doing this. Now everybody's adding these things, which is kind of fun to see. Yeah, we were onto something there. So we're a bit, I want to say, a little bit trailblazing in that regard. But the one thing that sets CouchDB apart from everything else is clearly its replication protocol and implementation. When you say, well, replication, a lot of other databases have that as well. We can do primary-secondary replication like many others, but we also can do multi-primary or peer-to-peer replication, which is fun if you have a lot of locations across the globe that need need the data that you have. Like if you want to build your own CDN, but for your data, you can do that with CouchDB. You have a server in South Africa and Australia and Japan and the US and Europe, and everything can replicate with each other, and all replicas are live and can be written to and read from, and it all just works out. And that was what it was designed for. But the really fun part is now that there are a bunch of implementations of that replication protocol that work in other environments like mobile phones and browsers. And now we can build offline first apps that where all the data lives in the cloud somewhere, but also on a person's device, like a phone or a browser, and they have access to that data always, not only when there is an internet connection. And we're kind of the only database that does that. And if you need a way, help think about that, maybe CouchDB is more like Git than any other database, where you have a local copy and you push to a remote and you can push to your colleagues, and maybe you have a CI server that has stuff. So if you will need a mental model, it's a lot more like that than like a regular database.
And Couch has been on really the bleeding edge. I mean, you talk about the fact that it has basically a REST API with HTTP. When that came out, databases were going a different direction at the time. I mean, everyone was building brand new fancy drivers that were not HTTP, and it was very cutting edge, and still is, as you say, right? I mean, you guys do offline, which most others do not do at all.
It's a lot of the things in CouchDB are constraints of us being a small team. Which is interesting because we were like, we don't have time to write like a language driver for Perl and PHP and Python and Ruby and so on. So we just make an HTTP API, then everyone can do that. It's a really interesting development that now a lot of people are going, okay, we need to build microservices with HTTP and whatnot, and then CouchDB is just one more HTTP API that everybody knows, which is kind of nice.
So you talked a little bit about distributed scaling. Distributed scaling's a kind of hard problem. Couch does it really well, but I think some developers have a hard understanding of it, because when you start small and then you grow to something large, scaling can be sort of an enigma. It's very difficult. What is distributed scaling like? Like, what's the CAP theorem, and why do developers need to know these things? Why should they care? So
fundamentally, it's Garren. If you don't mind, I'll take this one.
I mean, you've pretty much given the perfect summary of CouchDB, and I'm not sure if there's much more that's worth this podcast. We could have just stopped it now. But,
all right, so folks, thanks for tuning in. So CAP and distributed databases and all that. It may all sound fancy, but it boils down to very few things. That at a certain point, you can't do everything on a single computer anymore. And there are various reasons, like I have too much data that fits on a single machine, or the failure rate of a single machine is too big for my operation, or can't handle the number of requests and all that kind of stuff. And as soon as you have a single system that runs on two computers, physical or virtual, you have a distributed system and have to deal with a bunch of inherent properties. And most databases were designed to live on a single machine that within an operating system process that has access to all memory and full I/O of the system. And in a distributed system, you have multiple machines with varying I/O, with network that sometimes is there or not, and that has a bunch of interesting consequences. And the most famous one of this is called CAP, and it's kind of if you've ever heard the meme of here are three things, pick two, CAP is kind of the original one, and it stands for consistency, availability, and partition tolerance. And the saying usually goes that you can pick two of those in any distributed system or specifically database, but it's kind of not true, because as soon as you have two machines that are connected over network, you have already chosen partition tolerance. So you can either choose consistency, which means all data looks the same everywhere at all times, or availability is you can always access some version of the data, but you may get inconsistent results. And while that might sound scary, under the hood, most big operations websites deal with the consistency bit in clever ways, so that end users actually don't ever see inconsistent data in their end.
And Couch implements eventual consistency, correct?
Eventual consistency is kind of a cop-out from the people who build databases that focus on availability to say we have some form of availability and it's eventually consistent, which there are degrees of consistency, and that's true. And having no consistency is obviously a bad idea, but there are certain guarantees. Maybe the canonical example for this is the Amazon shopping cart. Amazon always wants you to be able to put stuff in the shopping cart, but they can't do that while checking with all their fulfillment center if they actually have that one copy of that book ready for shipping for you. So they would say, yeah, you buy this now, it's fine. And then a half hour later, when they're actually processing your order, say, oh, shoot, we don't actually have that copy, and they give you a $20 gift card, and then you're a happy customer. And instead of building a very expensive system that could check this in real time at that scale that they need, they just cop out and trick around that.
Yeah, I just figure at this point, something like at the scale of Amazon, I just presume it eventually shows up at my house. I mean,
yeah.
And I think sometimes data is like that too. Eventually, that data should go to the place it needs to go.
It is interesting. Have you ever tried to sync an address book?
It can't be done.
Sometimes multiples
it can't
show
be
up.
done.
Exactly. So either you get multiples, or some stuff just randomly disappears. And that's an interesting, fact. There are very few sync operations that actually work. Like in Git, if you were to do Git syncing, because we build software with it, which has to be in a very precise format to actually work, we know reasonably well that Git does reliable syncing. But even Git can introduce conflicts, and then we have to do something about it to get data in shape again so that it actually works. And it's very similar with Couch. The replication works. You guarantee to have all data at all places, but sometimes it can be in a state where a human has to decide, do you mean this phone number or that phone number? And there's no way around that. And yeah, there's a few optimizations that you can make around, but fundamentally, some things computers can't decide, and that's where humans have to come in.
So,
okay.
Tell us why Couch does it better than the other systems out there that we may or may not mention at some point.
So the type of synchronization that CouchDB does is unique to databases, as far as I know. There's no other database that has a completely different system. There's a database system called Couchbase, which is kind of a sibling, which is technically a different database, but they implement the same algorithm that we do. They're kind of part of the family. But there's no here's our own version of this thing that is an open source database. The closest that is available as a commercial product is Lotus Notes. And before you go screaming and crying.
I'm not crying. I'm waiting. I mean, I'm interested in finding out why this is a great analogy.
So the person who invented CouchDB has worked on Lotus Notes in the early 2000s on the core database thing, and they realized this is actually a really good idea. And I forgot the guys. Ray Ozzie invented it in the late 70s and early 80s, and it's a solid way of doing this. It's like inventing Git again, but for databases. And then we kind of need this as an open source database, so I'm going to build this. So CouchDB is kind of a logical successor to Lotus Notes and that solid syncing. And the business case for Lotus Notes was businesses and people with how are they called? I'm blanking. Sorry. People who go to customers,
CRM.
Yeah, people who go to customers, talk to stuff before the internet, right? Before people could live connect to everyone's cloud and cluster, and they have a laptop, load all the customer data, go to the customer site and show them all the stuff, put in new orders, then come back to the business, and everything syncs up to the cloud, as it were. So that's where CouchDB came from, and there's no other system like this. So we're not only better than everyone else, we're the only ones that are doing this. If you think about why use, I keep mentioning Git as an example, so why don't use Git? implementation of Git is geared to like low numbers of requests. So people at GitHub will probably do this, but they have been putting a lot of time and effort into making like at least the read and write operations go fast with their servers. But it's generally meant to be like a low volume kind of thing, whereas CouchDB is a proper OLTP database that can like take your big traffic and be useful on the web. Right.
And it implements. I mean, when we talk about documents in the CouchDB world, we're talking about JSON docs for the most part. We're talking about JSON in a DB, and you say JSON, and web developers everywhere cheer, and at the same time go, oh, because it's JSON, and JSON, for as good as it is, can be problematic. Why JSON? Why not some other random format of things?
So JSON's like democracy, right? So I'm actually a big fan of JSON, and I know there's problems around it, but then there's again solutions around the problems. So I'm just usually going with those. It's a pragmatic choice. At the one thing I haven't mentioned yet, and then Garren can talk a little bit more. A lot of stuff in CouchDB, the querying and a bunch of other things are done in JavaScript. So that's a native. Like JSON is just a native data type there, and then since CouchDB was kind of built with the web in mind, everyone using JSON. Specifically, the one thing that I keep coming back to, other protocols try to be a superset of all the fancy data types that all the programming languages have, and JSON is the common subtype. Every language can serialize their native types into JSON, but not the other way around. So I can deserialize a JSON object in Java and serialize in Java and deserialize it in Python and make sense of it. And that's a really freeing situation without having to write parsers and binary transport and everything for all of the different ones.
And Garren, you hate JSON, right? You're the opposite, right? Someone's got to be the opposite of. I don't have any problem with JSON. I agree. I think it's endlessly useful for that. But Garren, I'd love to hear your thoughts.
Yeah, I must say, as a JavaScript programmer, I kind of love JSON, so I'm afraid I am on the same side as Jan there. What's really nice, I mean, as Jan was saying, I mean, CouchDB is built for the web, so it's quite intuitive. I mean, if you pick up a new language and if you pick me up, say, Go or any other new language, and you want to go, does this language work with CouchDB? I mean, a lot of other databases, you automatically have to kind of download that specific database library and then make sure it works like that straight away. As long as you've got some kind of HTTP.
It also has that one dependency on that other library that other thing is depending on, but then can't be installed because then your Linux is broken and all that kind of stuff.
Yeah, you got the wrong C++ compiler somewhere, and it's chaos. Whereas with CouchDB, you just immediately, you've got the HTTP client, and you can immediately start working with it. Obviously, there are some great wrappers in any language you have over CouchDB to kind of make some parts really simple and easy to do. But JSON is awesome, and I think the way CouchDB works with the kind of the document storage, it's interesting. Jan was talking about replication and the way it syncs, and I think that really is the power for us. Is the original kind of CouchDB 1 series, up to 1.6, which is the latest release, is that replication is its power. We're getting multiple databases to sync and being able to talk to each one individually and get that eventual consistency. It really is a game changer, along with kind of it has a changes feed, which is really nice, so you can actually see what's happening in your database. There are other databases that do that now as well. But with CouchDB 2, which is the next thing we're kind of going to be working on next, and I think I'm kind of a bit of a spoiler alert because I think we're getting to it eventually. But that takes that replication to another level and builds on that and builds this clustered design, which really takes CouchDB to the next level and competes with all the other kind of clustered databases.
So let's talk a little bit about Couch 2.0, if it's on the horizon. What kind of new features are sort of on the docket?
Yeah, the first one, obviously. Sorry, Jan. Do you mind? I think we're gonna have like a little bell that we ring, and then you can see which one speaks first. So the big one, obviously, is clustering. That's kind of come out of there's a software as a service called Cloudant or database as a service, what they kind of like to be called. And they originally took the original CouchDB and they've now made it clustered. And now that's been moved back into the Apache CouchDB Foundation or project. And we now, instead of typically you would have kind of your single CouchDB instance, now you have multiple nodes across multiple machines. and it then makes your CouchDB instance a lot more fault tolerant. So you can it's a lot more durable. It can also then handle a certain higher level of scale as well, because you've got kind of your data nicely distributed. So that's the really big one that everyone's really excited about. And then there's some really nice other features as well. One of them is actually called
Because you carry on, because the name Couch is a backronym in the sense for cluster of unreliable commodity hardware, and CouchDB 1X, while it was designed so you can set up your own clusters and it works eventually consistent, all that kind of stuff. If you want to do fault tolerance, you kind of have to detect if a node is down and then route data or your clients elsewhere. And it can all be done, but it's a lot of work. Not a lot of work. It's some work. And CouchDB 2.0 finally fulfills the promise of this clustered solution, where we actually implement the thing. When you set up CouchDB on like 10 machines and one of them fails, you will not notice. You can bring it back up again later. To fail, you never notice, or your end users never notice. You hopefully notice. You can bring them back up. So, and that goes up to, I haven't made, we should do experiments of or you should spill how big cloud clusters are. But that goes up to lots of machines that you can have a lot of capacity and fault tolerance there. So that's the big one.
I think it kind of gives you the opportunity to run, databases up in the terabytes, and still have a nice kind of response time and usability. From that, we've also done, so CouchDB works in doing queries, and the way we query data is used kind of MapReduce. And the one thing we realized is that it's powerful. It's not quite like SQL, and so because it's not like SQL, a lot of people find it a little bit difficult to learn. So the next thing we've kind of introduced is this new querying engine called Mango. And actually, Mango underneath is using kind of MapReduce, but on top of it, it's got this nice querying syntax. And that syntax is actually based off of MongoDB. So that kind of comes in as well in top of CouchDB 2. And there's some nice added features to that. And we're really excited about that, especially for people learning CouchDB. It's a really nice way to start learning how to do querying. I've got some on my team who are not familiar with CouchDB, and the moment they've discovered Mango, they feel a lot more comfortable already just being able to query the data without having to spend a lot of time understanding MapReduce just to get some basic queries out. So those are the two big ones. Another one which is really cool, and Jan's probably more of an expert on this one than I am, but is this whole idea around a database per user. So with CouchDB, we can kind of build, it's often recommended to actually build a specific database for a user of your project. So if you've got kind of whatever app you have, every time someone signs up, you actually create a very small database for them, specifically to them, and then you can replicate data to that, and then kind of you can manage a really nice security model around that. And then, Jan, I don't know if you want to add anything in on that part.
Like other things, the stuff that was possible in 1.x, but it's going to be a lot more easy and built into 2.0. So a lot of the default use cases for CouchDB are now kind of out of the box.
Yeah, that's exactly. I think that's really nice. It's kind of a consolidation of the ecosystem into things that are much easier. That the way people were doing it is now much easier to do. And then we've got a lot of kind of smaller changes, like the global changes feed. There's like a bulk get. So a lot of kind of just general big improvements on how the whole system works, really from a lot of feedback of people using CouchDB over the years.
Maybe one of the things where we really show that CouchDB was built for the web is that it comes with an admin interface, so you don't have to install something like phpMyAdmin on top. And from day one, we made it to look good as opposed to many of the other admin UIs. And 2.0 comes with a completely rewritten one. When we started out doing the original called Futon, which should give you an idea, we have been through all the furniture puns. That was way before there was front-end JavaScript routing and whatever. So that is Christopher Lenz did a really good job of wrapping up a jQuery project that kind of worked, that looked amazing. But over the years and with more and more people working on it, it wasn't clear. It was more of a it's hard to maintain. Let's say that. And then we decided, okay, let's start over and let's start using modern tools. Backbone was kind of the hot thing when we started, and we built a new thing called Photon, which is a faux futon, if you still follow the puns. Because
I would like to just say that I was not involved in the naming of either of those.
I think the history goes that a bunch of people have tried to replace Futon and then never went anywhere, and then we just gave up on betting everything on it and giving it a proper name before we see any action. So we just came up with a silly name to see where it goes, and this one stuck, of course. And then Garren can talk a lot more about this. But we started out with Backbone. It is now in the process, if not done, being rewritten to React because that's kind of better. But yeah, Garren, you take the lead on this one.
Yeah, we're so close to moving it fully to React because obviously we want to stay with the cool kids, so we're moving to React. But that's kind of how I actually joined the project. Was I got involved at building Photon. I was kind of always a user of CouchDB. I actually have a product that runs with CouchDB on the back end. It's called Classroom 7. And I kind of started lurking the IRC channels, and I saw a couple of the team members looking at building another UI. So I then kind of got involved with that, and then it actually came out of Cloudant. They originally started the idea, and we kind of built on top of it. It started out as a Backbone project, and one of the things we've done with this UI is we also want to make it as modular as we can. So you actually find if you go to a couple places, you see the same dashboard, but with slightly different coloring or variety. So you have the default Photon, which is served with CouchDB 2.0, or it's actually done as a kind of a preview in the CouchDB 1.x series, but that version's really old, so it's a bit embarrassing, so don't look at that one. But the new one's is much better, and it's, as I said, it's very modular. So you actually have CouchDB, which we'll get onto later, and they actually have a couple of variations of Photon running as well. And the way we built Photon is that you can add or remove modules. So they've added in specific modules they need to support CouchDB, as well as Cloudant uses Photon as well, and they add some of their own modules on top of that, and that becomes the Cloudant dashboard. So if you ever sign up to Cloudant, you'll see that same dashboard, same code, just with a couple of modules added on.
And different colors.
Different colors, obviously. And just a brief history of it is that, we started it in 2013, and in those days, Backbone was kind of the de facto way of building kind of a JavaScript single-page app. And we started to kind of, as we built it further and further, we kind of started to reach some points where it was a little bit difficult to do the stuff we wanted to do. And we started looking at other ways of doing that. And one of the easiest ways, instead of, we didn't want to do a full rewrite because a lot of the stuff was good and usable. So we started realizing that we can actually add React in and start migrating towards kind of a React-only platform, but still keep our Backbone going as well. So we've kind of done that over the last year. It's a bit of a slower process than we'd like, but it's just, that's software for you, really, I guess. And so we've got the majority of the stuff running in React. We've still got some Backbone stuff, and it's interesting. I think that's a really exciting part of a kind of an open source community, and we haven't quite nailed it, but it's something that we always have in the back of our mind. Is when you build software in an open source community, you actually want it to be something that other people can pick up and use, and that's one of the biggest things we disliked with our Backbone stuff. Is we actually built a lot of custom code. So anyone new coming into that code would say, "Oh, I know Backbone. I can totally get involved here." And they'd look at it and go, "Whoa, what is this? I have no idea what this is." And then that immediately leaves. So we didn't get as many contributors as we want. So one of the big things with moving to React is we're trying to use as many de facto tools and standard tools that are out there. So someone looks and goes, "Okay, you've done one or two things your own way. That's fine, but I get the general kind of gist of what you're actually doing. I can actually contribute." And so we're getting there. We're not quite perfected that part yet, but I think we're kind of moving on that. And that's one of it's the unique side of an open source community is you're building software that works, that's good, but you also want to make sure that people can get involved.
And involvement in open source is hard, right? I mean, not from both the people building that tool as well as the people trying to recruit other people to build for that tool, because you can have great docs and you can have very clean code, good entry starter bugs, but it is hard to get that initial contribution, isn't it? And any sort of barriers to that entry, you really do have to eliminate, I think, which I think a lot of projects, including CouchDB, do quite well because, one, it's got a very vibrant community, and two, it's structured in a way that allows people to contribute. There are a lot of projects out there that want contribution but don't plan for contribution. They don't have that, "Oh, well, you should be contributing." Well, your docs are horrible. I don't even, where do you start? And why is all your source minified in your tree? I can't work with ACF. I don't know what that means.
Or even just like, hey, you haven't looked at my pull request for a week, and then well, it's like somebody just like put out something that they thought was really useful, but they don't have time to maintain it, and now somebody gets angry because they don't look at the pull request, and it creates pressure on both sides, and that kind of needs to be resolved. That's a lot of stuff.
Yeah, you see that a lot now, don't you? The single project of a great many stars on the GitHubs with 27 pull requests that are never going to get reviewed.
Oh yeah, I have a bunch of those.
I think that's where it's actually really nice being part of the Apache Foundation.
Oh yeah, good point.
The Apache Foundation does have a lot more bureaucracy, but behind that you get a lot more support. So you get a whole lot more structure. And within the CouchDB community, you have you got your PMC, you got your committers, and that kind of structure really helps it. So you have pull requests that people can look at. You got teams that can back you up. Doesn't say don't get a lot of angry emails. You do get there's been some entertaining email chains over the years, I must be honest. I'm amazed at how fast people can write a really long, angry email. But but I think that's all part of having a really good, vibrant community, is that you have people that are passionate about it. And look, there are cases when there are some pull requests that are neglected. But I think I'd say CouchDB is pretty good at reviewing pull requests and trying to get it as involved as we can.
Shout out to Alex from Russia, who is doing a lot of this.
That guy, I'm still not 100% sure that guy isn't a robot. He just seems to be online all the time and reviewing everything. He's amazing.
Or a bunch of people, I don't know.
Yeah, could be a name for many people.
But yeah, good point on the Apache Software Foundation. They have a mantra called community over code, and the idea is like if you bring in the right people that are enthusiastic about a thing, they will produce the right code to do this. If you have any single person who provides maybe does good code but can't be in the community or foster a community, then they have no business being part of an Apache project, which is severely focusing on making sure that a project stays around for a long time, as opposed to just having the coolest kids working on the coolest stuff all the time and being maybe potentially not very nice to each other. And on that topic, CouchDB was the first Apache project to introduce a code of conduct and a diversity statement. Very proud of the work from Joan and Noah on that part. And the Apache Software Foundation thought that was such a great idea that they just basically copy and pasted it to be the Apache Software Foundation's code of conduct. And now all 200 whatever projects on there have our code of conduct.
Nice.
It's an important thing to do. Yeah, I mean, I think it. I know it can be a sort of contentious topic, but I actually remember when that happened for Couch, when that landed, and I was like, ooh, this will be interesting. And then of course, Apache was like, yes, all of them shall have. This shall be a thing, which was a great thing to do.
And Apache often doesn't probably have the best standing in the open source community, because a bunch of things seem, and in fact are a little bit archaic, but them getting ahead of the code of conduct games. Okay, if these people who do the boring businessy open source stuff can get behind this, all our cutting edge stuff should probably also be on this. So really, really happy to set a precedent there.
Well, big foundations are tough, I think. I think people sort of forget that, when you're managing that many projects, I mean, you look at Apache, you look at the Eclipse Foundation, who have, like you said, right, they're not short-term, this project's around a couple of years. I mean, we're talking massively long-term outlooks which is key for developers who are developing sort of that next wave of things that need to power not just applications and things, but the internet itself. Yeah. Because I think a lot of people, when you start to get into the infrastructure things, like CouchDB, which has offline, which powers a number of syncs worldwide for a number of very large applications, that becomes a major thing that you need. You need a community around that to support it, and if you don't have the sort of tools and foundations to do that, I think that can be very hard to do by yourself, if not near impossible.
And then, the one thing that the ASF does, and this is the most boring part, but also one of the more fascinating ones, is that it produces a level playing field for commercial players. So there's Apache Hadoop, but then there's Cloudera and a bunch of other Hadoop distributors that do commercial work on top of it, but they all collaborate on the core as part of the open source project, and the open source project is way better off because of this. And the same with Lucene and Cassandra, and of course Couch, and multiple entities can come in and and go in and support the project, but no one can dominate it. Like no Uber can come in and buy CouchDB. And then, yeah.
Well, I remember the articles that said that was going to happen, like in 2000, 2001. Like, that was the thing, like, no, it's never going to work. The corporates will, destroy it all and take over, but really hasn't been the case.
Yeah, I've like the Apache Software Foundation had its 15-year anniversary last year, and I forgot the number, but it's like in the billions worth of software that we've written together. Try doing that. It's
piece of cake, right? You can do it tomorrow. So I realize we've gone a little bit far afield into other lands of software things, which is absolutely fine because we're all about the open source. But CouchDB was mentioned, and I want to talk a little bit about CouchDB because I think for web developers who, with some of the new tooling that's sort of available on the web platform these days, with things like Service Worker or not, CouchDB becomes a very powerful concept. Tell us a little bit about CouchDB.
Right. Maybe I'll give the intro, and Garren, you fill in the blanks.
Yeah, that's perfect.
Excellent. So CouchDB started out as this weird experiment that, hey, can we build a replicator in JavaScript that we can make talk to Couch? Originally started by Michael Rogers, who is now big in Node.js. Then that didn't go very far. Then Dale Harvey, who's now working on Firefox OS, took it over and made it a thing, kind of in between jobs. Spent a couple months just making it a proper thing. And despite not being part of the Apache Software Foundation, it's one of the most well-run open source projects I've ever seen. It's really, really fantastic what Dale and the team are doing. But it is a tiny CouchDB, hence the name. It told you we'd been through all the puns. That runs in your browser. It's written in JavaScript. It is an abstraction layer over all the various different storage systems that are available in browsers, like WebSQL, local storage, IndexedDB. Smooths over differences in the implementations and features, the brokenness, looking at Safari IndexedDB. In kind of a way that jQuery was kind of this normalizing API on top of the DOM in 2006 or 7, 5, 6, 7 when it came out, where we all had a DOM, but it was kind of different everywhere, so it was annoying. So jQuery kind of smoothed out the differences, and CouchDB is the same for storage. CouchDB is the same for storage APIs. Plus, it does this syncing thing that's really interesting now that we have a more mobile world where the whole idea of offline first is a little more important.
Yeah, I think that's a pretty good summary. I don't know if there's many gaps there, but the amazing thing of CouchDB is from a community side, it's got a great ecosystem. They've built great plugins, so a lot of things you want to do, they can got great plugins to help you do stuff. So at the core, you've got CouchDB, which is this great database to run in your browser that you store your data, in your browser. Or if you're using something like Cordova, you use it, build your mobile app, and you still got this nice, simple database that replicates beautifully back to CouchDB. So you can manage your data in a couple ways. You can do full-on sync, where you actually just, you're storing your database locally. If someone's not connected, they can still interact with the application as if they're online, and it just works beautifully. And the moment you get back online, it fully syncs it back up to your database in the cloud or wherever it's sitting. Or you can even just use it as something to do some fast cache. So if you've got a lot of data that someone's just going to always be reading, you can actually read that data, put into CouchDB, and then have a very fast database to read it. Well, a lot faster than if you had to fetch it, from a server. And then on top of that, they've built in some great plugins, things like authentication. I'm part of the team, I guess, who's building. We talked about Mango, that is the Mongo kind of query for cloud and for CouchDB and Cloud. I've now helped Nolan with that, and we're building out that whole aspect of it inside of CouchDB, so we can actually do those same kind of queries on a LevelDB or IndexedDB database as well. And then the other fun thing about CouchDB is you actually got CouchDB Server, which actually just runs in Node.js and runs on the back end. And that's actually, it's a really simple thing, but it's actually become really powerful. We use it for testing and quick things like that. If you're using Travis or anything like that and you want a very quick in-memory CouchDB instance just to run your tests with, that is actually genius and works really well.
Yeah, we use it for prototyping a lot.
Yeah, it's brilliant for that.
Yeah. And we're, like, as you can hear, we speak all friendly of all these projects. There's a few more, a thing called CouchDB Mobile, which does the same thing for native apps. And we're one big community that usually like talks to each other. And we've, like, last year was the first time when something that these like, say, ecosystem projects or satellite projects had requirements that were specific to them, like reducing the number of HTTP requests to do a synchronization. If you do it between two servers, it's less important. But if something is on a mobile connection and you have a latency of 5 seconds and not a lot of bandwidth, that costs a lot. So we improved the replication algorithm for the satellite project. So Couch doesn't specifically need it, but now because of the ecosystem, the technology gets better as well. So it's really fun to see all these projects coming in with their own specific focuses on that whole idea of having replicated data.
And I think one of the things that leads from that is that, like, you got CouchDB, which is your kind of de facto standard or API, but then you've got all these other instances that are kind of CouchDB-esque. So CouchDB is almost in some sense a database as well as a standard. You've got the replication protocol, but you've got this whole CouchDB protocol now that all these different databases implement, and then they can almost immediately connect to each other and synchronize data, or you know how to interact with them because they're all following this specific protocol, which is actually quite amazing.
The most far out idea that I've seen so far is this is the Drupal community. I think it's Drupal. They want to use or they are using this the protocol to do like staging systems, or replicating between staging and local authors and that kind of stuff. So usually you have like a centralized content management system and you have to be connected to it. But they've now built a system like CouchDB isn't the core database of this. But they use that to transport data to other instances of Drupal where I'm an editor. I can do all my work offline, kind of in the Lotus Notes sense I explained earlier. But they've implemented all that in Drupal. Like,
wow.
Has nothing to do with Couch or Pouch. It's just, I think they may be using Pouch for client-side stuff, but that's it. Like
when they replicate back, they're not replicating back to Couch. They're replicating back to their own API.
Yeah, back into Drupal.
And just using Drupal as the API.
Yeah. So yeah, I can do my content management editing. Well, I'm an author. I put in my thing. My editor is offline as well. They get the data next time with my article next time. They can do all they are online. I should finish the sentence. But then they do their edits, and I can approve them or not, and then someone else can put it live, and they can all do that in a disconnected fashion. It's early stages as far as I know, but like these people just started sharing up. It's like, yeah, this is a great idea. We should be using this, and then here's a demo, and all of a sudden they were doing this, and it's quite fun to see.
I was going to ask. I mean, it seems like Couch's the core killer feature is this replication ability. What about replicating beyond Couch? And you just kind of answered the question that it's maybe on the horizon that Couch becomes this engine that keeps everything in sync.
Right. The one problem with this to have one of the bigger the most frequent questions you get for CouchDB is, can I replicate with Mongo or MySQL or Postgres or whatever? And you can make that work, kind of, sort of, because you can use CouchDB server. It has a pluggable backend, and then there's a MySQL backend or Redis backend, then that works. But the data model is still defined by Pouch. So the JSON documents have an ID and a revision field, and they work in the way that CouchDB works. Mm-hmm. And you can't just take an existing database and make it sync. You have to model your data around how the protocol needs it, and then you can store it wherever you want. That's fine, but it's not an easy migration, and it's certainly not like we can't do it generically. And it's again one of those things that computers can't do for you. So you have to design around it.
Well, I like my job, so it's okay that they can't do that all yet.
Fair enough.
So to that line, I just want to say syncing is hard. Regardless, I think people.
That's why I got excited.
I think the kicker is that, and I know this is a topic of great debate because, particularly in the web world these days, because now with things like Service Worker, which work on an off thread, like, well, great. Well, I want to sync more data, and I know background sync is sort of being worked on now. But any sort of sync, and I think the one reason it gets debated a lot is that, excuse me, it's not very easy to do. One, it's typically requires if you have to mash systems together to do it, it gets really complicated. And once you have to do that at scale, it gets even more complicated. And then people start going, I don't want to do this anymore. Let's choose a different approach to things.
Yeah.
But to that end, like Pouch with Couch, and even with a secondary hook in the back, regardless of how you write that hook, it is rather feasible to do today, actually.
Right.
Even if you have to sit there and say, well, my data models aren't one-to-one. I'm going to have to write a piece of middleware to deal with this problem. And I think that's a lot farther than we were, 5 years ago, easy. Like 5 years ago, I mean, this was a nightmare straight away, where you had sync, but back to the address book example, it was a lot like that, where I don't know who this person is, and why is all my names backwards? No reason. But Couch does that rather well. And now, is that protocol specific to Couch? Like, when Couch does sync, like as it's going through and doing all of these sorts of things, because we've talked a little bit about the REST API. I mean, what does that sync look like? I mean, is it really... I realize syncs can be really data heavy based on, obviously, what data you have. But how does it sort of mitigate some of the, nightmare bandwidth problems that a developer might see?
I'll take this one because that's one of the things I think are very neat in Couch. The APIs are very nice, and they are designed for application developers, so they're like neatly contained and well documented. But they are also the same APIs that the replication protocol uses. And the fundamentals are there is an index of all documents by ID, so I can look like it's a primary key lookup. That's very fast. You need that. That's number one. Number two is a secondary index that's also always available in Couch called the by sequence index. This is a thing that powers the changes feed and what that Garren mentioned earlier. It is like git log or svn log, where you can see everything that has happened in the database since the beginning of the database. And that's not only a log, but it is very efficient to say, give me all the changes since the last time we talked, since last week, since the last time I was online, since last year. And CouchDB can then stream those changes, only these changes, to the receiving end, which can then apply locally. So if you keep track of what the so-called sequence index or sequence ID is when you replicated the last time, then you can ask CouchDB, give me the delta. So you don't have to check like very expensively. Say, give me all the data. Do I have all the data? Give me more information. Do I have that already? Do I have the specific version of this? We can say, give me the delta, and then for all the delta, I can look what do I have, and then I can tell Couch, okay, from that delta, I will need these things, these specific versions. And then the only other thing is that a single document isn't a single entry in our by a sequence or by doc ID index, but can be a tree of multiple versions, which is how we keep track of conflicts. So they have specific version numbers, like in Subversion or in Git. Just looking slightly differently, having slightly different properties, but between different versions of a document, and you can synchronize specific ones, and that's all there is to it. And then there's just a very clever algorithm to go through it top to bottom, and then that's it.
Nice. Yeah, I think that's I think a lot of that gets very confusing for developers when you start to go down that road of. Again, it can be a hard problem, and when APIs like that are clean enough that application developers who obviously, or sort of, I mean, I think a lot of people will go, oh, well, I don't work on DBs, so I don't need to know.
Right.
That's a statement I've heard a lot over the course of a career. I don't do the sequels. So it's nice when APIs that are available to application developers are sort of easy to grok and go in. I mean, and to the extent, beyond syncing, sort of going back into the syntax of MapReduce and Mango, do you find developers have a hard time querying data out of it? I mean, with the rise of sort of I don't want to call them simplified. I want to call them robustly nice APIs. It's gotten easier to get data in and out of things to some extent, but at the same time, you do have to know actually a little bit more. In my experience, I mean, do developers sort of take both to MapReduce and to the new Mango syntax? Like, is it leaps and bounds easier for them?
So it depends. TM, of course. There's a class of programmers that you tell them you could just query using MapReduce, and they go, "Whoa, cool, let's go." And there's others who go, "Whoa, let's not go." And for those, I think Mango is leaps and bounds better. Personally, not specifically a fan of how it looks, but I understand it's significantly easier for people to get into, especially since MongoDB is fairly popular. It is designed to be like developer compatible. It's not like bit for bit compatible, but like if you've seen the Mongo one, you can understand Mango, and that gets a lot more people interested in Couch. So if there's one downside to Couch, it is that querying can be a bit tough, and even Mango isn't as powerful as it could be in the future. But we're working on that, obviously.
I think what's nice with kind of Mango is it kind of piques your interest. A lot of the time people kind of use CouchDB. From my experience, the first time I loaded up CouchDB, I used Futon. I saw the CouchDB book online and started reading about it. I was like, this is brilliant. This is so cool. I could immediately put one document in, get one document out. I could look at all the documents in the database, and I was like, okay, wait a minute. What happens if I only want specific ones? And then they kind of, had to watch a couple of videos and really learn how to do MapReduce, where something like Mango is going to get you going very quickly, and you're going to immediately be able to pull out a bit of data. And then at that point, I think you kind of got enough interest and excitement in CouchDB that you're willing to put in a little bit more effort to kind of really understand that MapReduce aspect of it.
This strikes me as a strange thing. Do NoSQL databases need a SQL? Do we need a sort of standard set of querying sort of APIs and tools? And I realize that's an incredibly loaded question of things, but I'm going to ask it regardless. We're towards the end of the episode.
So Cassandra does have a SQL interface, so these things exist already, and I think it's a natural progression. NoSQL has never been about not being SQL, and it's a terrible name for what it stands for, which is
very true.
You kind of should consider your data storage model and then pick the best one. And NoSQL is just the best name, like the very sticky name. It has nothing to do with what it actually stands for, which just makes it a terrible name at the same point. But it's what we've got, so it's more sticky than it's terrible. I've actually been to 2 meetings of the SQL Standards Committee of the IETF here in Germany, and they are looking to standardizing a JSON data type for the SQL. So you could formulate like Couch or Mongo queries which are JSON enough to work natively in SQL, because they've done XML already, so they can just do another one there. And the other thing that is different in a 2.0 way, or something that React or Cassandra are doing, you can specify different consistency levels, which gets us back to the very beginning. It's like, okay, do I have a consistent snapshot of my data, or can I be a little bit fast and loose with this? And we kind of prototyped kind of how a syntax could look in SQL of specifying those NoSQL operations, and it would just work if we could implement. So eventually it'll be done. It's kind of like Homer Simpson. Databases are like Homer Simpson's car. Like they get all the features eventually. And I'm sure we're going to see that down the road. All databases will have a REST interface with JSON and a SQL interface with structured data. I'm way past this being like a religious fight. This is the better idea. It's just the one we chose in the beginning and went with it because it solved our 80/20, and for a lot of other people that as well. But like as further you want to go to be a general purpose database system, the more these.
You have to start somewhere at the end of the day. You can't you can't sit on design on paper all day long. Otherwise, nothing ever gets built, and then we all pack together our own horrible solutions because. If you've ever been down that road of saying, I want you to do it, no tools that ever, just build the entire thing from scratch. Those are bad days, I think, to some extent.
I think the biggest thing sometimes, when we try and look at standards for SQL, sometimes people want to know how one database works and apply it to every other database, and I think that's sometimes a mistake. Sometimes people try and use CouchDB for everything, and it's not necessarily the best case, or you try and use Redis to solve your relational problems, and that's not going to work either. So, I think sometimes this religious idea that there's only one perfect database is a bad idea. You've got to use the best database for the job. And, CouchDB is brilliant at sync. It does great JSON storage. It's got a REST API. If those are the needs you have for a project, it's perfect. If you want something that's incredibly relational, maybe time series or something, CouchDB might not fit your usage that time.
That actually leads me to, I don't quite trust when everything I hear about something is 100% positive. So along those lines, when would somebody specifically not use CouchDB? I mean, you kind of hinted at it there, but are there any good examples of that might help people understand the differences?
If you are in a situation where you have, like if you think in keys and values, if you have a key that gets updated a lot, like a counter or updating a sum or something, and you need that to be really, 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 really fast, you do that in Memcache or Redis or Mongo. If you need something that can handle a lot of write requests that come maybe as part of an analytic system, you probably want to look at Cassandra or HBase in that regard. If you want to have this built-in clustering stuff, you have to wait for Couch 2.0. You can start using the alpha today if you want, but there's a different database called React which has similar properties, but they already have the clustering, so you probably look into React at that point. If you have software that already runs with Postgres or MySQL, just keep using that. It's fun. They're fine databases. They're really good. If you've put in the work to learn a lot, if your operations people understand the failure scenarios, just don't jump onto the NoSQL or any other bandwagon just because of it. Yeah. It's whatever you're most comfortable with. It's if you're exploring stuff, go wild. But if you were I'm betting a business on this, or a hobby project that I can't invest a lot of time into, use something that you trust, so that you know how to yell to get things fixed. Then you're probably good.
Makes sense.
You do see a lot of hybrids these days, though, don't you? I think I do find it interesting that for such a long time it was this thing, that thing, and that was it. Right, you had the one thing, the ginormous thing in the back that was the only thing everybody used. It seemed like there was 3 of them. These days, the ecosystem's quite full of really good things that really fit little niches in your sort of workflows that make life so much better.
Yeah, my standard stack is Couch for the data. Hello, dog. It's all right. It's Couch for the raw data, Redis for caching and fast things, Lucene or Elasticsearch for full texty stuff or more advanced querying, and Postgres or MySQL whenever I need something else. and then Memcache for the front end web caching stuff. So that's 4 to 5 data stores already that do their thing really well. I think that's pretty normal.
Yeah, I mean one of the apps I built or worked on it. It's kind of quite hybrid. Was we kind of have Postgres for very relational stuff, CouchDB for kind of document storage stuff, and Redis for kind of key value stuff, and that works brilliantly. Just combining those well on top of Rails actually worked really nicely and gave us quite a lot of flexibility.
Right.
So we've talked a little bit about CouchDB 2. If someone wants to play with it, how do they play with it today?
Oh, dang it, did you remember? Sorry, go ahead.
Well, I was just going to say it depends on how brave you're feeling.
I am terribly brave sometimes.
You answer it. You've been doing a lot more of that work lately.
All right, we'll put a link in the show notes that gives you a bunch of instructions for what to do. The simplest way is to clone a Docker image and then take it. I don't even know if that's the right term. But you do a thing with a Docker, and then you have a Couch cluster. You can spin it up locally or in DigitalOcean real quick. It's 90 seconds to Couch or something like that. And then you can start playing. So that's not very hard if you know your way around these things. If you're very brave, you can install everything from source. I would not recommend doing that. But if you're really brave,
that's why we have Docker.
Exactly. It's like the PDF generation for the documentation, which is a part of the regular build, needs LaTeX, or LaTeX. So there's a bit of a rabbit hole going on. So Docker it is. And then
if you're installing from source, sorry, Jan, if you're installing from source, you can skip that documentation build parts. That does that saves you a couple gigs worth of downloading and makes it a little bit easier.
Yeah, that's true. I'll put a link, and there's like a link on our website to like try out the 2.0 alpha. And we have a weekly news on our website, blog.couchdb.org, that points to all of that every week as well.
And if people, I realize we're getting close to time, if people want to find you guys and reach out, where can they find you? Where are good places to go?
The official domain is couchdb.apache.org, and then couchdb.org redirects there. Everything is on that front page. Official project business happens on mailing lists. I'm sorry, I keep saying that. Bug tracking is in Jira. We're working on GitHub compatibility there. But if you want to do actual development, it is all in Git and on GitHub. GitHub.com/Apache/CouchDB is the entry repo, and there's a bunch more that are linked from there to get into that. You can send pull requests into that, and we can integrate it from there. So you don't actually have to do all the archaic ASF stuff that we have to do, but you have your good GitHub experience. There's an IRC channel on Freenode, CouchDB, and CouchDB-Dev for development stuff. And then the blog, basically, it's one of another thing that we've pioneered for a bunch of open source projects. The weekly news, we have someone who goes through the project business every week and says, hey, these are the most important discussions on the developer side, on the users mailing list. Here are the OpenStack Overflow questions. Here are the things where you can get started applying patches. And here's what happened with CouchDB, and here's the article that came out. And every week, half of the stuff is in there that I hadn't seen otherwise. So, like, if even for someone who's like really deeply involved with the project, there's a lot of stuff going on that I wouldn't see otherwise. So it's definitely a great resource.
Great. And where can they find you guys on the socials? Twitter handles, things of that nature?
Garren?
Well, I think there's CouchDB. I think it's just at CouchDB for the official Twitter one. For myself, it's just at Garren Smith.
And I'm at JANL.
Fantastic. Well, thank you both, gentlemen, for being on the show today. We really appreciate it.
Yes.
Thank you. Thank you for having us.
Yeah, it's been brilliant. Thanks a lot.
And thanks to our panelist, Sharon. Thank you so much again for being on today, Sharon.
No problem.
Yeah, thanks, Sharon.
Thank you.
And this has been, indeed, another episode of the Web Platform Podcast. Check the show notes for all the links that we discussed today, as well as other interesting materials. I've been your host today, Justin Ribeiro, and we hope to see you next week.